So when it comes down to it, the main thing you do in an IDE is work with code. And I think we can all agree that code should be source controlled. And the clear winner nowadays is obviously Git. So it's Git that I'm going to demo in this video, but Rider does also support Mercurial, Perforce and Subversion. But as I say, I'm just going to be demoing Git here, and as you'll see, Rider has a very nice, deeply integrated Git experience. So here's a project I'm just going to use to demonstrate the Git functionality in Rider. If you look along the left-hand side, these different panes, there should be one called Git, which is Alt and F9, or might be different depending on your key bindings. If that's not there, then choose ... it'll be hidden in here. And then when you go to it, it should then appear down here. As a side note, if you want to tidy this up and get rid of the ones you don't use, you can right click and say hide. So if we go to the Git pane, then we see this along the bottom. So first of all, this video is not a Git tutorial. I'm assuming you've used Git. This is more how to use Git in Rider. This should hopefully look quite familiar. So on the left-hand side, we've got branches. So we've got local branches and remote branches. In the middle, we've got the log, the Git log with a list of commits. And there's a bunch of filters along the top, which we'll look at. On the right-hand side, you've got the details of the currently selected commits. So we've got the files, and we've got the commit details with things like the char, the author details, the timestamp, and branch information. Right near the start of the course, I mentioned about keyboard shortcuts to move these panes around, not just Git, but any panes. So if you remember, if we go over here and go to resize, we can see them here. So they've got stretch to top, stretch to bottom, and maximize tool window. So this is actually really useful for this log window, especially the maximize tool window. So the stretch ones do this. And the maximize tool window, which in my case was Control Shift and apostrophe, basically toggles it being full screen. So this applies to all panes, but for the Git log, this is especially useful because for a big project, this log might be quite busy. And just being able to do that and have the full page viewing it is quite handy. So in this example, you can see that I've got my main branch, which is behind the remote origin main by 1. Now I've put the commit message commit by Bob. Ignore the fact that it says my name against it. Pretend this is a commit by someone else that's on main, and I'm 1 behind. I've intentionally done this so I can demonstrate rebasing in a bit, but we'll come back to that. So let's work through a scenario from when we first start writing the code to creating the PR. So to keep it simple, let's say the requirement is to create a new API endpoint. This is a web API project, and all it has to do is return hello Dome train. So the first thing I would do is create a feature branch. So there's a few different ways I can do that. I can right click here and say new branch. I can do it from over here and say new branch from main. There's also on the top left, we've got this drop down, which shows your current branch. It shows some kind of indicator, see this blue icon? So that shows that we are 1 commit behind. So at a glance, we can see that. And I can update, so that's like a poll kind of thing, which I won't do now. But then we can work with our branches here. So, well, we'll come back to this a bit later, but we can create a new branch here as well. Another option is this menu here, as well as getting to it via here, you can press Control Shift and backtick, and then that pops up exactly the same menu. So if we could say create new branch and we say new API endpoint, that'll do. So press enter. So that's created that now. So we can see down here that's appeared. We've obviously not got a remote representation of that yet. So now let's start with the feature. So I can see we've got a test project, and in the next module we'll talk more about tests, but let's go to this one. So this test project is making an API call to my demo controller. But while I'm here, I've noticed that the file name isn't ideal. So let's do Control RR to rename this to fix it up, just while we're here, because it's always good to leave things better than how you found it. Now I can do Control RR and rename it here, just to quickly show you a different refactor, which I don't think I showed you earlier on in the course. If we actually just change it manually, let's call it my demo endpoint test, because that's what the controller is called. Then if I'd done Control RR, it would have intelligently renamed the class and the file name and all usages. But because I've done it manually, I'm now in this situation where the class name doesn't match the file name. So again, Alt Enter. There is an option saying rename file to match type name, and that's updated it. So I realized I hadn't actually shown that refactor, which is one I use quite often earlier on in the course. I thought I'd just show it then. So obviously normally you do Control R to rename it, but I just thought I'd do that. So that's renamed. We've got our feature branch now, so let's commit that before we continue. So over here, you've got this commit pane. Now it doesn't actually show a shortcut next to it, but I happen to know it's Control Alt K. I'm not sure why it didn't show the hotkey next to it. And this is how you commit in Rider. And you can see by pressing that, this has got focus straight away. And it's automatically checked my file. So going back to our code, we're coding away, Control Alt K, fix existing test name or class name. So Control Alt K literally just typed it straight away. I can reach for the mouse and do commit, or I can do Control Enter. And that's committed it straight away. And I can press Escape to bring focus back to my code. So you can see by using this inline in your IDE, it's not really taking you out of the zone. You're not alt-tabbing or switching to a different Git GUI or the command line or whatever. You're doing it whilst you're coding. So that really encourages staying in the zone, but also committing often as you're working. And you can see that appeared down here in my feature branch. So now because the requirement is a new endpoint, I'm going to do Shift Alt and L to show the current file in Solution Explorer. I'm going to do Control C, Control V. So that's going to copy that file. And let's call it, so the requirement was an endpoint that returns hello dome train. So let's do that. Endpoint tests. And I'm just going to copy that name and put it into here because I did copy the file. And then let's just close this out of the way. So the only change I really need to make here is that the endpoint should be hello dome train. So we've now got a failing test. I'm not going to run that because in the next module we'll talk about tests, but now just know that we've got a failing test. So I want to commit that. So Control Alt K, add failing test. Control Enter. And we can see this failed because it wasn't selected automatically. That's because it's a new file. If I click here and add it, then we can do commit. So now we want to create the new endpoint. So Alt and F1 to bring up Solution Explorer. I want to go, let's just copy and paste my demo controller. And it was hello dome train controller. I'm going to copy this because as we saw last time, because I've just copied and pasted the file, it's got the wrong file name. So I'm going to paste over the top of that. And that's fine. So let's commit again, Control Alt and K, and I can type add and then paste hello dome train controller, Control and Enter. And again, we need to select it. Commit. So let's do a few other changes. So endpoint test, let's say that I'm just going to duplicate this and say content.read as string async. I just need to await the thing. And then should be hello dome train. And then Control Alt and K again. Update test to return string and Control Enter. So it went from passing to failing. So if I go over to the controller and get that to return hello dome train, Control Alt K, make test pass, Control Enter. So you can see how I'm staying in the editor and it's very easy to do very frequent commits. If I do Alt 9 now, we can see all those commits I've just done. So I won't make any more changes because that's a good example of just doing regular commits. I just want to at this point show a few things over here about committing. So you've got this cog window. This shows a few options. I don't really change them, but this is of interest, the check to do. Now later on in the course, we're going to talk about to-dos. Down here, this one, this is the to-do pane and you can configure various to-dos. I tend to have one, if I go to filters, called Dan, and I added this myself, Dan colon. So I tend to encode, say I, let's go to the tests, and I want to do a to-do comment, something like that, add unhappy path tests. But because that matches my to-do comment, it's then come up in this list. But if I just close this, if I go to commit that and say add comment and control enter, then it's popped up here on the bottom right. Just a subtle pop-up saying that there's a to-do comment in there. I wouldn't want it to be in your face and not subtle because I commit often. But at the point I want to push, so let's talk about pushing. Again, up here we can do that, and we can do push or Control Shift and K. And then we get the option to push, and we can do like a force push. But at this point, when I push, this is a bit more in your face. It's red, it's showing that the commit has a to-do comment. So, and I can review it here, and then I can decide, oh, actually, I had forgotten there was that to do there. I don't want to commit this temporary code. So that's really useful. Another way you can deal with temporary code is Rider has a concept of change lists. And we can see we've got this changes here. But if I right click, I can say create a new change list. Let's call this temp and then enter. So one of these will be the default change list. So when I created that new one, I didn't tick set active. So this is the active one. So if I make any changes, that's the change list it's going to appear in. But say I didn't want this committed at all, and it was just, I wanted it locally, but I want to commit often, but I don't want that committed. Let's just go back to Git. I'm just going to right click and say reset and do a mixed reset just to undo that commit so we're back like we were. So we've now got this change, which if I click on it, we can see that's the diff. If I drag that over to this change set, so it's now in here, so that's this comment, then I can carry on working. If I make some other change, whatever it is, then you can see this appears in changes. So this is the one that if I'm here and I control Alt and K and do some commit, then my temporary change set isn't ticked. So it's not going to commit that. So that's a really useful way of having a bunch of temporary changes you don't want committing in a different change list so that you can carry on committing often without committing those temporary changes. And there's various other use cases for change lists as well. It basically just allows you to have your different changes grouped together so that you can commit them individually. And it's worth pointing out that if you've used Git, you probably know about the concept of staging a change before you create a commit. So Rider kind of hides that away from you. If you do want to do that, you can go to the settings, so Control Alt and S. You can go to version control, Git, and you can turn this on. Note that by turning on the staging area support, then it will disable change list support. So you do have that option. But let's get rid of this change. If I right click and say roll back, so that's basically discard or Control Alt Z. So I can discard those changes. And it's actually asking me saying that the temp change list is no longer used. Do you want to remove it? So yeah, let's do that. And whilst we're talking about committing, another thing you can do is you can see these checkboxes here. If I just close this down and make a few more changes. So imagine, let's just get rid of that. So I've got no pending changes. If I go to like program, let's get rid of this for a sec. Imagine I've got a file with multiple changes in. So let's just say my method one. Let's put this down here somewhere. So I've got something like this, and then Control Alt K, it's ticked it all. If I click on here, you can see it's got them all ticked, but I can choose to untick some stuff. And you can see that over here, this has become a minus sign to show that we're not committing the full file's changes. So that allows you to do like partial commits of some changes in a file. I can right click and do revert for just that section, or you can highlight and right click and revert or move to another change list. So it's quite flexible for just committing parts of a file if you need to. Again, let's discard that, right click and roll this back. So Alt F9, let's revisit the log again. So I want to show a few extra things whilst we're here. In the settings, you've got these options. On single click, update branch filter or navigate the log to branch head. This one is the default. I would recommend changing to this. What this does is when you click the branches here, you can see that it highlights that commit in the log. So that's really useful if you're working in a team and there's lots of different feature branches, just being able to click around. Another thing that's really useful is if you double click, So I mentioned about these filters here before, and you've got your branch filter. If you double click on a branch, then that filters by that branch. So that's a quick way of making this view much simpler. So you're just looking at the branch you're working with. You can also do this drop down and you can select whatever branch you want to filter by. You also, if you favorited anything, so if let's say my new endpoint is a favorite, and say main is a favorite as well. So you can favorite them by just clicking the star icon. So if I go away and come back, you'll see that I can filter by favorites now. And you can see here it shows head or main or my feature branch. So that's really useful for giving you really good control over what you're viewing in your log. Some of the nice bits of functionality, you can right click on a commit and say show repository at revision. And then what this does is it actually shows the entire repository at that point in time of that commit, which is really handy. You can click on and you can look and even view it in the editor, what the code base looked like at that point in time. Also very similar, if you want to compare two commits, you can control click the two commits and you can right click and you can say compare versions, and that brings up the diff up here. So again, you can click through. So I think that was a new file. If I click here, find something with a different solution, here we are. So it shows the differences. So you can click through and view them here as well, which I find is a really nice way of diffing two commits, especially if you're working on a feature branch which has lots of commits and you want to see all of your changes. So as an example, let's select main, which is what I branched off, and let's select the head of my feature branch, right click and say compare versions. Then I've got this up here so I can see everything in my feature branch. So even it says renamed from unit tests. So it's told me in English what's changed. If I go to one of these and double click, that was a new file, or these are both new files. If it wasn't, it would show the diff. Other things we can do with the history, if you've got, let's just take one of these, and if you right click on a file, you can say history up to here, and that will show like the log of just that file, which is quite useful. Another option is in your editor, you can do git annotation. So you can right click on the gutter and choose annotate with git blame, and it shows, this is a bad example because there's no changes. Let's choose something else. Let's do the controller and then right click and annotate with git blame. So you can see slightly different color. That was a different commit, and I can click on that and it'll appear in the log. If I click on this one, it'll highlight that commit. If I right click on one, I can say annotate the previous one. So if I want to keep on looking back through the changes in this file to really find out at what point a change was made and why it was made, like look at the commit message and find out information, this is a great way of doing it. This is basically doing a git blame. So if I want to close that, I can right click and say close annotations. Now, as far as pushing and pulling is concerned, as I showed before, this drop down, you can say update, which kind of does a pull. I personally prefer to just do fetches. I don't like the concept of pulling it because a pull is a fetch and a merge both together. Then quite often people do that and then it kind of makes erroneous merge commits, which you don't need. I won't get into that now, but I personally prefer doing a fetch beforehand so I can see what my log is at. Has it pulled down someone else's changes, for example? Do I need to do a rebase? And you can do like shift and then fetch, or you can do the shortcut that's against it, alt shift and K. So if I do alt shift and K, you can see at the bottom it's doing a fetch. No one else has committed, so it's not pulled anything through. As far as pushing is concerned, again, you can do push, control shift and K. We saw this briefly before when we had the to do comment. So this tells you, and you can look through what the changes are, and you can double click and you can view what the change was, or can view all of the changes. And then I can push. If I've done like a rebase or interactive rebase or something, so let's push that. So that's now pushed my feature branch. I can now see that on main, there's actually another commit by Bob. Again, ignore the fact it says my name. This is just a demo, but imagine this is by someone else. Or there might be a bunch of commits that other people have done that's now gone into main since I started my work. So I want to rebase against this. It's as simple as right-clicking on the branch you want to rebase against, so origin main, and choosing rebase, so rebasing my branch against origin main. So that's now rebased on top of Bob's commit. But we can see I've got like the two different versions. The one that's been pushed already, which had that branch divergence, and my new version, which has rebased out that branch divergence. So I just now need to do a force push. So if I do push, Control, Shift, and K. So if I try and do it now, then it's going to reject it. So I'm going to cancel that because it doesn't give me an option there to force push. And I'll do Control, Shift, K again, and I can do this drop down and force push. And that's done. So obviously in Git, force push don't do on the main branch. You can do it with a feature branch, that's fine, as long as you're not collaborating with someone else on that feature branch. So now I've not got this branch divergence, and it's a nice linear history, and I'm up to date. So the next thing I want to do, I've done my work, and I've pushed the feature branch, it's up to date with the latest. I want to create a pull request. So this project is on GitHub, so I'm going to use GitHub pull requests, and here on the left we can see we've got a pull request pane. And again, ... it might be in here if you've got it hidden. So I'm going to click this plus to create a new one. Now, if I had to push my feature branch, it would give a warning here saying you've not got a remote version of your feature branch, but it will give you the option when you create the pull request to do it for you. But I've already pushed, so it's not done that. And you can see it's here, you've got this arrow, so it's saying my feature branch going to main, which is what we want. So let's create the pull request. I was a bit trigger happy clicking there. I should have pointed out that around here, before I clicked create pull request, there was an option to set the PR title and a description as well. But I've now got a pull request. We can see up here, because it's on GitHub, there's a hyperlink to open it up on GitHub. I can view the timeline. So it shows the information about this pull request. And if you've got AI enabled, the AI assistant subscription, then it'll even do an AI summary of your changes. And then if I close this, then because it's filtering by me, if I get rid of that, we can see my PR listed because it's not actually assigned to me. A couple of other small tips before we wrap up. If you're in the log and you click over here, double click on one of the commits, one of the files in it, let's find something that's a diff. This one. So if I double click here, it shows the diff. If I want to actually open the file, I can press F4 here, and that opens the source file. In the same way as, I'm not sure if I've mentioned this so far in the course, but if you go to like a project and press F4, it goes to the source of that project, the CS proj. So it's a similar kind of thing. If I want to click down here and view the actual source, not a diff, then I can F4. Another small tip is you've got, as well as this log pane, you've got the console pane. If you click here, it shows the actual raw Git commands that were called. So that's quite handy. If you do want to use external tooling for diffs, for example, if you go to the settings and where is this? This is in tools, I think. Diff and merge. Then you can tell it to enable external diff tools. So WinMerge, for example, if I now save that settings, go back to the log, go to one of the files, if I double click now, that's going to open up the diff in WinMerge. So you've got the choice of using external tools. So I've probably shown you enough for one video, but as you can see, Rider has very, very deep and powerful Git integration. And I've used a lot of Git GUIs in the command line. I've done a lot in Git. And I've got to say, I really love this as a Git GUI. They've done a really good job. So the last video was very long, so I'm going to keep this one very short. So Rider has this concept of local history, which has actually saved me a ton of time before when I thought I lost lots of work, but Rider saved the day with its local history. So what this does is Rider keeps track of your changes. So this might be useful if you don't use source control, but you should do really, or if you've made too many changes in between commits and you've lost something. So maybe you've made too many changes that undo can't save you, but you've not done a commit, then this can save the day. So basically, if you right click on a file, you've got this local history here. If you right click somewhere in the Solution Explorer, you've got local history. If you right click on a project, you've got it somewhere there. If you right click on a solution, it's there. So you can do this at various different levels. Let's just use this file as an example though. If I right click and go to local history and go to show history, then this pops up. Now ignore the blah, I'll explain that in a second. But this is basically different changes. So things like if you delete a file or make a significant change, Rider will keep track of it. So I can click through and see what the changes are. We can see when we've done things related to Git that it's also tracking that. And this example, as we saw, is just in the scope of this one file. There's various different viewing options. So you can say unified viewer or side by side, whichever you prefer. And yeah, various different options here, like show line numbers or that kind of thing in this diff view. You can also right click on a change and say create a patch. So that creates a patch file. So for example, if I do that one and show an Explorer, then we can see that here. I could then share that with someone if I wanted. So local history is designed for personal use if you need to get back some of your own changes, but you can export it if you want as a patch. So if I drag this into the window, we get an option to apply the patch. So you could share that with a colleague if you needed to. I mentioned about this blah before, so basically, let me close this. If you right click on a file and go to local history, you can say put label, and then you can type in a label just to give that a more meaningful description, that point in time. And the last thing I want to mention about this is that the default retention period is 5 days. If you go to settings, so Control Alt and S, it's in advanced settings, but if we just search for local history here, and then go down to advanced, it's this one here. So duration of stored changes in local history. So you can change this if you want more or less. If you want to disable local history altogether, you can set that to 0. So that marks the end of this module. In the next module, we're going to delve into the world of testing. Hey again. So in this module, we're going to talk about testing in Rider. And this is not a course on testing, so we're not going to talk about why you should test and the benefits of testing and unit tests versus integration tests. We're going to focus on the functionality in Rider around testing. And to demo this, let's create a new project. So let's go to File, New Solution, Class Library. Let's call it Shopping Cart Lib. And this can be just a .NET 9 class library. So typically in .NET, you'd create a new project for tests. So let's do new project. And down here, we're going to say unit tests. Let's call it shopping cart lib.tests. And again, .NET 9, everything else is fine, except for this dropdown, which defaults to NUnit. I always go with XUnit, so let's do that. And then create. So that's created our new project, and we've got an empty test class here. And you can see, and I think we've shown this before, we can see we've got some triangles here, play buttons. And then if you click on it, you can choose run, debug, cover, profile. We'll talk more about these later, but let's just do run. So that's now built the project and run this test. So if we go down here, this now introduces this pane, the test pane. So here is where you would get to it if you wanted to just click and open this pane, or Alt and 8. Again, if it's not here and you've not opened it, it's probably hidden in this ... menu. And you can see because the test has passed. Now in .NET, obviously there's nothing in it, but unless it explicitly fails an assert or throws an exception, then that's a test pass. If I say, let's do assert true, so that's a passing test. And I'm going to select this and do Control D for duplicate. Let's add another line there. And then call this test2 and then make this false. So now if I want to run both of these, I can either do it at this level, so that'll run all tests within this class, or I can literally just run all tests. So if we go down here, we can see we've got tabs along the top. So if I close this one that's just opened, we can see Explorer has all of the tests that have been discovered. And again, I can right click and say run and do all these things. Clicking here, I can run the selected test, or here runs them all. Now it says Control Alt and Enter, but that only applies if this has got focus. If I'm here and I want to run all the tests, for the key bindings I have, it's Control U and L. If I do Shift and do run all tests, it's this one. Run all tests from solution, we can see it's Control U, L. If yours is different, then maybe do Shift and find out what the mapping is here. So if I do Control U, L now, then it's going to run all the tests. And we can see we've got red here now because obviously one of them has failed. And you can see here, we've got this. And with these buttons here, we can filter down. So if I only want to show failing tests, I can do that, which is useful if you've got a lot of tests and a few of them are failing and you want to work through and just show the failing ones and you want to work through fixing the failing ones until you've got them all passing. If you're doing that, then this button is quite useful. and that's rerun failed tests, or control UF. So that means that as you're trying to get all your tests passing, you can run this so that the ones that have already passed, you're not running those again. You're just focusing on the ones that have failed. If I untoggle that, then it's going to show them both again. If you do have a lot of tests, so you don't want to run them all every time, but you have a specific subset of tests that you want to run, then what you can do is you can say it was just this test one, for example, or even like a grouping. So you've got different scopes here. So you've got your tests, your test class, your namespace, your project. So I can right click somewhere and say create new session. And what that does is it opens up a new tab with just those tests in it. And I can pick and choose what tests are in this session. And I can even right click and say rename session to something else. So that does this box here. It's worth pointing out, we've already spoken about debugging, but when you go to run a test, you can also debug as well. So if I put a breakpoint here, for example, and then right click or click here, wherever, and do debug, then it's hit the breakpoint. So everything we covered in the debugging module applies here. You can run a test and you can see all there's no variables in scope here, but you'd see all the local variables. You can use the immediate window. You can view the call stack, basically everything we covered in the debugging module. So let's stop debugging here. So let's delete this block and let's start on our shopping basket. So let's create a new system under test. Is new shopping cart. And let's say this first test is new cart should be empty, something like that. And then let's say system under test, get should be equivalent to an empty list. So let's go with that. So obviously this is failing at the moment. It's not even compiling. So we're going to use Alt Enter to create the type shopping cart. I'm now going to do Alt Enter again, and I'm going to say move to shopping cart. So move to its own file. Then I'm going to, up here, I'm going to drag the shopping cart into our library. So it's not in the test project. And then we can see we've got a bit of yellow here. So Alt Enter and Enter again, basically fix up the namespace. Okay, so if we go back to our test, now it still can't find it because our test project is not currently depending on our main project. So we're going to talk about dependencies later on in this course, but for now, I'm going to right click here and say, add a reference to the shopping cart project, add. So that's now found the reference. So the next issue we've got is that there's no method called get. So again, we're letting the failing test, and it's failing at the moment because it's not even compiling, drive our implementation. So Alt Enter, and I can get Rider to create that method get. So just press Enter, and it's created that for me. If I go back to my code, then it can't find this method. Now I actually use a NuGet package, and again, we're going to talk about NuGet packages later, but if I right click and say manage NuGet packages, for now, I use a library called Fluent Assertions for my asserts. So let's do that. Very popular library, I would highly recommend. And this gives a nice fluent syntax, and I did this wrong, it's actually that. And if I do Alt Enter to import the references, and it's still not showing, I've probably spelled that wrong, be equivalent to. Okay, so that's there. It's failing because shopping cart is returning an object, not something that's a list. So if I go back to here, that was control click, and then change this to what we want a list. Let's call it a string. Let's keep it simple. Then we have this. So let's try and run our test. So we've got a failing test. It's failing because our implementation is not implemented exception. So now we've got a failing test. We can see here we want to get this to pass. So all I need to do is return an empty list at this point. So one shortcut at this point, which I use a lot, is Control U. So U is kind of the entry point into the testing shortcuts. A lot of the shortcuts revolve around Control U followed by another character, or somehow involve the U key. But Control U repeats the last test that you ran, or the last set of tests you ran. So the last one I did was these. So at this point, if I do Control U, it's rerun that, and now it's green. So in this video, we're not going to write any further tests. We're going to save that to the next video where we will expand on this. And we're going to talk about code coverage and running your tests continuously whilst you develop. Before I finish this video though, I just want to add a few extra tips. So one thing that's really useful is when you right click somewhere on a test or over here or somewhere, you've got this run unit test until fail. Now this is really handy for if you've got a flaky test, which maybe is failing sometimes based on timing. Maybe you've got some multi-threaded code or something and occasionally it fails. You can right click and say run test till it fails, or even better, debug unit test till it fails so that your debugger will catch it, then go and get a coffee and come back and hopefully you'll have the failed case in your debugger. Another nice little tip, which I've only just discovered in the documentation, I didn't know this existed, was that if your test generates two files, you can get the UI to nicely show a diff. So for example, I won't actually demonstrate it, I'll just show the documentation, but this is highlighting a bit weird, but if I select this so we can read it, if you've got a test that outputs something that matches this regular expression, so for example down here, then this will specify two files, and then you get in the test output window a hyperlink in the output, which if you click, it will open up the diff of the two files in your editor window, so the split screen view. So I thought that was quite nice, so I thought that was worth mentioning. Speaking of this output window, I kind of brushed over that, didn't I? So let's have a look at this. So we've had passing tests, so this is kind of empty. If I make a change here to make it fail, let's just say blah, and control UU to run it again. So that's now going to fail. Then on this side, we've got a description of why it's failing. It's also worth pointing out that in your tests you can, so say I did console.writeLine, some log, something I want to log out. Now you can see how it's got this underline. That's because with XUnit it's recommended to use iTest output helper instead. So Rider can do that for me. So Alt enter, and it's changed it for me. It's created the constructor and it's injected it in. And actually we've got another suggestion, and this will be primary constructors. So let's do Alt enter, convert to primary constructor. I'm assuming at some point they'll update that to be just one pass rather than two, but at least you can follow those warnings and suggestions that Rider gives you. So if I run this again, so I can control UU or just right click here and then run unit test. It says shift and enter, so that's another option. We can go down here and shift and enter. So it's failing, and if I scroll down, then it's not there because I've put that after the failure. So let me just move that up to here. And again, I mentioned it earlier on in the course, I'm using a Vim plugin, which I'll talk about later. So me quickly moving that up was using Vim. If I undo that and just do it without using Vim. So I've used it that long, I forget I'm using it, but I didn't want to turn it off because when I'm watching videos of other people coding, I actually quite like to see how other people code day to day and what their tools and things are. So I intentionally haven't turned this off because this is just how I code. But I'll mention the idea Vim plugin later on in the course. So let's control UU again and scroll down. And now we do have it. So we can see that's logged it out. Some type of output. So you might have something failing. Maybe you're doing like an integration test and you've got some failure which doesn't appear down here, some logs that don't appear. What I recommend doing is if you put a breakpoint in your code or further down or wherever it is that's after what the log is that you'd expect to appear. Maybe it's an exception that's in some thread or something, and then you debug it. So I can click on here. I can right click and go here, or I can just do Control D. So because that failed, that's actually hit here. But because we're in the debugging view now, if you go to console here, then in my basic example, I've not actually got any normal output logs. That's not a test helper output. But if my code or the threads or whatever, or I was doing an integration test and there was something that wasn't appearing in my test output, this would be where I would go to look for more information. Because quite often I've found that this is where the clue is. And another thing we can do is when debugging, do you remember this breakpoint? I mentioned earlier that you could click this to stop on any exception. Sometimes if your test covers stuff again in another thread or it's an integration test or something, sometimes clicking this so the breakpoint stops on that exception and it doesn't skip past any handled exceptions, then sometimes that can be really useful as well, making sure that's turned on. So if your test failure isn't obvious, which for a small unit test it should always be, should be quite a pure method call, but for integration tests it might not be, then making sure that's ticked when debugging the test is useful, and also just checking out the console output for more information. So that's a basic intro to the Rider test UI. In the next video, we're going to look at code coverage, but also continuous testing. So whilst you're coding, the tests are running in the background for you without you having to explicitly run your tests. So continuing on from the last video, we're now going to look at code coverage and continuous testing. So we've got our shopping cart, lib, and tests. The shopping cart isn't actually doing anything except returning an empty list. If we go to the tests, then that's all we're checking for at the moment. If I press Alt and F8 to get the testing pane up, then we explored this in the last section. We did mention that there's this concept of covering all tests. And if I click on this, then there's two things to note here. One is that we've got these bars in the gutter pane. If we go to our code, we can see we've got it here as well. So what that means is that the tooling has detected that there's tests covering this code. And because it's green, it's passing. Another thing which you might get, which I've turned off, which I'll show you in a sec, is over here, there's this test coverage. So we've got a pane here. So by I've turned it off, I mean, you might have had this pop up immediately. If we go to settings here, and I think it's in the root of .cover, then there's this option here. I think this is the default. I actually don't like this popping up, so I've turned it off. But if you're following along and you run that cover, it's possible that this popped up as well. So here is showing your project, and we can see we've got 100% test coverage. Obviously there's not much to the code, so that's quite easy to do in this case. So if I add a new method, say private void blah, and remember Control-Shift-Enter kind of completes that line and intelligently adds braces. So Control-Shift and Enter, that's quite a useful keyboard shortcut to remember. And then just do something like console.writeLine, let's do that. So it's worth pointing out that we've got this bar here, which is quite confusing. That's not related to these bars which we're talking about here. This left-hand bar is related to Git, because these are new changes since I last committed. If we hover over here, we get this pop-up, which I didn't actually mention in the Git video, but you can do this inline commit just this change as well. And you do get some kind of gutter highlights to indicate what's new, what's been changed, what's been deleted. But for this video, it's the bars to the right of the line number that we're interested in. So if I do cover again, then we can see that these have changed. And over here, we're not on 100% code coverage anymore. We can see here we've got grey lines. So grey lines means that this code isn't covered at all by tests. There's no tests that run this code. So at a glance, we can see which parts of our code aren't protected by tests. If I delete this now and save it, then it hasn't updated this. If I go to the settings and then go to continuous testing, then there's this option at the top saying whether to trigger it on build, save, or you can even configure your own shortcut. If I tick save, so I think the default's just build, and then I save now, and then I go down to this button here, append test to continuous testing session, and then I save, then we can see it's immediately updated this. It's run the test again and it's updated this. So just revisiting that, we've got this button, continuous testing is on. I can right click on a test and say, well, we've got these options here, which are grayed out now because this test is already part of the session, but we can set the selected test to continuous testing, or we can append it to the existing one. But basically any tests that are down as continuous testing, as we code, so if we go actually to our test now, let's just collapse this. And let's say, oh no, let's go back to the actual main code and return something else and save. So we can see that's run straight away. I didn't have to run those tests. And we can see that the test has failed. We can see we've got some red in the gutter. If we go over to the tests, we can see we've got red here as well. If I was to update the test to match, let's just copy this and go in here and save. Then as soon as I saved, that's rerun the test, and now we've got some green. And again, we can go back into the shopping cart and we can see green here. So quickly before we start adding more methods, I'm going to go back to the settings, so Control Alt and S. So we're on build execution, deployment, .cover. So that's where we were looking when we were looking at the settings a few minutes ago. So we looked at this bit, and .cover, we looked at this bit. So .cover is actually a separate JetBrains product, and it's a standalone desktop application. I believe, if I remember correctly, some of this functionality in Rider required that to be installed. But before recording this video, I wanted to double check whether that was still the case. So I've actually uninstalled .cover from my machine, and it still seems to be working. So it looks like this is now built in. Maybe that's always been the case, and at some point I've just dreamt the fact that you needed .cover installed. But now it looks like that's not the case. But just in case you're wondering what this term .cover is, that's what that refers to. So if I close that, so I've got continuous testing on. I've turned it on for all the tests. And you can see it's actually created a tab called continuous testing. And actually, I take back what I said before. When I said this was grayed out because it was already added to the session, it would actually be this is grayed out because I'm in the continuous testing tab. But if I go over to here and right click, then they're not grayed out. So we can set that as the continuous testing session, or we can append it to that session. So click here and see what's in this continuous testing session. This UI has actually changed fairly recently. So if yours looks different, just make sure you've got the latest version. So let's smooth that down a little bit. And I'm going to create a new test. Let's do fact. And let's say add our product. Control-Shift-Enter to do that. In fact, let's fix up this one because I did this just to demo something before, didn't I? So if I delete that and go back to here, we can see that's actually running automatically without me doing anything. And I'm going to delete that. And as soon as I save, it's doing this because we're in a continuous testing session. So back to our tests. If I say var sort equals new shopping cart, and sort being system under test, set dot, and let's say we want add. Let's just do add and Docker course. Let's say our product is my Docker course, which is also on Dome Train. So first of all, we need to get this to compile. So I'm going to do our favorite alt enter and say create method. So that's added it to our shopping cart. I'm just going to tab through this and say product. Let's just call that product. And then back. And we can see already, because we've got continuous testing, we've got some red here. So I'm not even having to think about these tests. I'm just writing the code and it's doing it for me. So then I actually want to assert for something. So it's failing because add will be throwing a, if I control click, not implemented exception. But let me copy this line here. And I'm going to bob that down here. And a get should be equivalent to Docker course. So I'm now happy with this test, but it's failing. So we need to make it pass. So control click shopping cart. We need to implement this now. So at this point, we kind of need to, we've got an add and a get, which have been called by the same test. We need to have some kind of persistent storage, and that can just be a local field. So for now, if we just say private list of string, and let's say items, in fact, we can new it up here as well. And Resharp is telling me that I can alt and enter and use a new syntax. And again, another suggestion, alt enter, use collection expression. So that's a lot cleaner. And over here, we want to say items.add product. And we can get rid of this and save. And it's still failing. And we can see that we're hard coding what it's returning. So let's change that to items and then control S for save. And now we're green. Got a suggestion here, some green. So let's do alt enter, make it read only. Yep, we'll have that. And we can see we've got lots of green. We've got green where our tests are passing, where we've not even explicitly run them. It's been run for us. And we've got some green up here. The right-hand green, which was spoken about earlier in this course, shows that we've dealt with all the warnings and suggestions and things. And we've also got this that says that our code has been covered. So lots of green, which is always good. So that covers most of the things you need to know about testing. A lot of it is quite self-explanatory, where if you click on something, it explains what it's going to do. Again, we're going to cover profiling in a different module. So that now marks the end of this module. In the next module, we're going to look at how to deal with dependencies. And we've already touched a little bit on referencing other projects and adding a NuGet package, but we'll delve more into that, and also the tooling that Rider has to help you manage your dependencies, especially when you've got a very large code base. So in this module, we're going to look at how to work with the different types of dependencies in Rider. So NuGet packages, project references, type dependencies, and also tooling to help visualize this in Rider. And in this first video, we're going to focus on NuGet. If you've used .NET before, you've probably heard of NuGet. If you've not, basically it's .NET's package manager. So similar to NPM and Maven and that kind of thing. So let's have a look at the Rider UI for that. So down here, there's a pane Alt 7, as usual, ... if it's not pinned to the side, or you can press Alt 7. So let's do Alt 7 and this appears. Let me just drag it up a bit. So this is the NuGet tool window or pane, and we can see that there's a few different tabs along the top. And it's this tab that you'll spend most of your time in if you're adding a NuGet package or updating NuGet packages. So you can search for new packages here. You've got various filters along the side, so we can say we're dealing with the scope of the entire solution. You can choose what feed. So if you've got your own private NuGet feed, maybe on Azure DevOps or somewhere, then you can filter it here. You've got an option saying pre-release. So this list would then include pre-release versions, and you can install the pre-release versions. We can see there's different groupings. So these are install packages. And note that if a package is out of date, it will show on the right-hand side the new version. So we can see this, for example, is 17.11.1, but the latest is 17.12.0. We've also got this block, which shows, so implicitly installed packages refers to transitive dependencies. So if you're depending on a package that depends on other packages, that's what these are. For example, I'm depending on XUnit, which in turn depends on these three. Even though that's out of date, I can't click on this and then say update the version. There's no option to update it because it's indirect, it's transitive. Scrolling down a bit, there's other sections like available packages. So when you start to search for something, say like, let's go with Fluent validations. So we can see that's not installed, but it's available, and this is the available list. And then you can click and say, just install on the right-hand side here. Speaking of this right-hand side, when you select a package, you get the details here, including information about the package, like number of downloads, publish date, the author, various links, and frameworks and dependencies as well. You can choose your project here and click the plus if you want to install it into that project. You can also at the top change to a different version or choose a different NuGet source. So if I X that and move across to the next pane, sources. So this lists out the feed sources. So we can see we've got like the NuGet source. If you've got your own private feed like Azure DevOps or somewhere, then that will be listed here. We can see on the left things like the NuGet configs. So this is my NuGet config, but there might be one in your project, so that's source controlled, which I'd probably recommend if you're using a third-party private NuGet feed, so a new developer would automatically have that set up. But you can see how it's kind of layering them together, and we can use this pane to investigate where our packages are coming from. The next tab, folders, basically shows where the NuGet related folders are on your machine. So things like the NuGet cache, the downloaded packages, there's the package cache, where the cache folder is, and various other related folders. The last one, log. Now this can be really useful if something doesn't quite work right. And an example might be if you've got a private feed and you've got an authentication error, so it's not authenticating. Go into this log, might show you more information. And quite often, an example being Azure DevOps might be that it requires an OAuth authentication flow. So it will give you a link and you've got to go to it and enter a code or something like that. So sometimes it just stops working, and go into this. You can actually see the hyperlink in here and the one-time passcode in here as well that you can then do that. Speaking of private feeds, it's worth pointing out that if you go to the settings, so Control Alt and S, and build execution, deployment, NuGet, if you go down to the bottom, there is this credentials provider setting. And if you are using a private feed and you're having trouble, then try changing this to NuGet.NET CLI plugins instead of Rider integrated. Or this one, which is hidden at the moment, the ending, but it's basically NuGet.NET CLI plugins, then Rider integrated. So it's like a fallback to Rider integrated. So try switching to one of those if you have trouble with Rider integrated authentication. Whilst we're in the settings pane, if you type password up here and system settings passwords, we can see that there's this option for how it saves passwords, and you can see it uses KeePass, so that's where it stores your private feed authentication details. Okay, let's close that, and we've gone through all the tabs now, and I've already said that Alt7 shows this tool window, this pane, and doing it again toggles so I can get rid of that. Another really useful NuGet shortcut is Shift Alt and N, and that brings up the NuGet quick list. So you can quickly do restore, force restore, you can manage your NuGet packages, and there's all these options here. So these go directly to the tabs we've just discussed. So if I go to sources, it opens that straight up. So going back to packaging, I've already shown finding a package. So Fluent assertions, I can click here and then let's collapse this. I can just click on the plus icon. We can see that Fluent assertions, I did Fluent validations before, but Fluent assertions is already installed. So if I want to remove it, I can click on this bin icon here. But I can see at a glance that it's installed in the test project, but it's not installed in the non-test project, the main class library. The package, if I just X that, the package we saw that was out of date. So we saw it's in the installed section, but it's got a new version here. I can then click on that and I can do, you can see on the right, this icon here, I could upgrade that. Another option on the left toolbar is that I can click this to upgrade all the packages in the solution. And I can do a NuGet restore here, I can refresh, and I can go to those settings we saw earlier. It's worth noting if I just collapse that a bit, and if I go to one of my projects and press F4, in fact, let's do the test one instead, because that's got package references. You can also get IntelliSense here. So if I just do a new package reference and say include, then you get autocomplete. So let's just pick one at random. I can say version equals, and it also looks up the version, so you get that IntelliSense, you can see your versions. So if you prefer to just edit in the CS Prod, you can do that as well. So as you can see, doing this in Rider, installing and upgrading packages is quite easy. What about creating your own? So we've got this shopping cart lib that we created before. You can just right click on one and go to advanced build actions, and we've got the build and rebuild and clean and things. You've also got pack. So that, clicking that will generate a NuGet package. But that's a manual action. Another thing you can do is right click on your project and go to properties. In here, we've got NuGet. So you can click generate a NuGet package during build. You can populate this. So let's just say title is shopping cart library and then OK. And then if you go to Git, then we can see it's made a change and it's added information to our CS proj. Generate package on build is true, and it's given it the title. If you'd filled in any of the other properties, then that would also be here. The last thing I want to show in this video is if we go to, let's go to our tests and let's just create a new test. What I'm showing here isn't related to tests, it's just somewhere to put some code. So if I did, let's, as an example, do that. Now, HTTP test, I happen to know, is a class that's in a NuGet package called Flurl, which is an HTTP client library, which I find quite good. But at the moment, I've not got that referenced. So here I can actually do Alt and Enter, and you'll see there's this option here, find this type on NuGet.org. If I click on that, it then opens this, and you can see this T : syntax. So that's found it by type, and we can see I can click on there, and I can just add it straight away. So if you know the type, so you've typed it in code, but you haven't referenced it, that's a really quick way to add the NuGet package. This T syntax, obviously you can type manually in here. You can also do N instead of T for searching for a namespace. So those are the main things you need to know about NuGet and installing and upgrading packages. In the next video, we're going to look at Solution Explorer and how we can use like dependencies to look at our project dependencies, and also how we can set project references. So see you in the next video. So just a quick video this time, we're going to look at project dependencies, and we're also going to look at this expandable project dependencies section. So first of all, we've seen the solution so far, and we know that the test project depends on the class library. We've already done this, but let's remove that dependency. So I'm just going to delete. So I pressed F4 here. I'm going to delete this. So that's deleted the dependency, and we can see we've got compile errors now because it's gone red. So now if I want to make this depend on this, I can right click on dependencies and say reference. And we have a list of projects, and I obviously can't reference it itself, so this is grayed out. So I can click this one because that's the only other project in there. So if we click add, then we can see that's now re-added that back in again. So that's fairly simple. So let's have a look at this dependencies section now. If I expand this, we've got imports. So this is all about the props and target files. So I can drill in on these, and going into props and target files is out of scope of this talk. But basically all the properties that get imported are like here, and then the actual targets, so the tasks and things, are here. So these all relate to the build, like MS Build and that kind of thing. You will very rarely need to dig into this, but it's there just so you're aware. If we then move down to here, so this project targets .NET 9. So if I expand this, we can see all of these things. So assemblies. So these are all the assemblies it depends on. And you can see it says implicit. And these implicit assemblies are even including DLLs like from NuGet packages that we're using, as well as system assemblies as well. And then moving down to projects, we can see the project reference. And then moving down to analyzers, then this is really cool. We can expand these, and it actually tells you the description of each of the rules. If you right click, you can configure the inspection severity, which we've spoken about before, not from this view, but we've spoken about it before from the code view. You can also open a help link, which will open the description of this in the browser. And then we have packages, which are our NuGet packages. So going back to F4 here, we can see those are listed here. You'll see that Fluent Assertions has a chevron thing, so we can expand it. So that's when the NuGet package has a DLL in there. So you can right click and you can view it in the Assembly Explorer if you want to disassemble it or view its symbols. You may be thinking, well, how come XUnit doesn't have DLLs in? Surely that's got DLLs in. The reason is that this NuGet package actually doesn't have DLLs in, but it has transitive dependencies to other DLLs like xunit.core. And in fact, if we right click and open in Explorer, and then we go into here, so new pack, so the NuGet package, a NuGet package is actually just a zip file. So if I double click to open it in 7-zip, which is what I've got a new pack associated with, then we can actually see if I drill into these, there's nothing there. Content, no DLLs, rels. But if I open the new spec file, I think this isn't a zip file or a new pack, so I can't drag it onto Rider. But if I close this and go back to that file explorer, there should also be a new spec next to it. So that's basically what's in the zip file. Let's drag that onto Rider so we can view that. We can see here we've got the dependencies in here. So basically that's a package without DLLs, but it's got an assembly in. If it had DLLs, it would be expandable like this. The last thing I want to show in this video, which is very useful, if you right click on a dependency, you've got find dependent code. If I click on that, that's opened my code that is using that library that depends on that NuGet package. So I can double click and go straight to it. So that's really useful for finding what code is using this dependency. Or I can click on something else. I could click on a project reference. And then that's showing me in my tests what's using this project reference. So as you can see, there's lots of useful information here to help you discover your dependencies. In the next video, we're going to take it further and look at, for example, if we right click on something, we can click on diagrams, and we've got various dependency diagrams. So we're going to drill into that in the next video. So in this video, let's have a look at some diagrams. So by right clicking on something, let's say here, so this project, you can do it on a class as well. You've got this diagrams submenu here, and we've got show type dependency diagram and show project dependency diagram. There are other ways you can get to these, especially the type dependency one, but let's just start with the project dependency diagram first because that's the simplest. So here's a very simple diagram. Near the end of this video, we're going to show a much more complicated version using a different project. But let's start off simply. So we've got both projects here, and I can drag these. If I want to show and hide them, I've got this pane here, this project diagram pane, and I can just check them and uncheck them, and then they disappear and appear. I can right click and drag around. I can control and scroll wheel to zoom in. There's also various options along the top around zooming, and we can even export. So we can export to an image, or we can save it to a file. You've got this concept of grouping, which is this icon here. Now, if I had solution folders, so if I right click on a solution and say add new solution folder, which is a way of grouping together different projects, then that's what that grouping would show. You've got show transitive references, so that's a reference of a reference. This one is interesting though, enable coupling analysis. So what this does, if I just drag this up, so you can see we've got a blue line here. Coupling analysis actually looks at your code to see if there are actually any real dependencies, if there's any coupling, like with the type system. So I've got this disabled at the moment, and it's worth pointing out that coupling analysis for a big project is quite resource intensive, but it can do the calculations in the background. If I enable this here, then obviously this is a very simple project, and nothing's changed because I do have things in here that are depending on this. And if let's create a new project. It can just be a unit test project. Let's leave it as is, create. And then we add a project reference. So right click here and do reference to the main project, add. And then if we go back to our diagram, so we've now got this. And if I disable and enable coupling analysis, then that's now updated the diagram. And we can see that we've now got this dotted line here. So at a glance, we can see that test project has a dependency on the shopping cart lib, but we don't need it because there's no actual coupling between those two projects. If we hover over this blue line, so the thickness of this line when we have coupling analysis enabled is thicker if there's lots of different usages. And if we hover over, we can see there's 8 code usages. If I click on it, then it's going to open them up down here. So this is really powerful for investigating your project references and determining if you actually need those references in the first place. So let's close this, and now let's have a look at the type dependency diagram. So we can go again to here and go to diagrams, and let's choose type dependency diagram now. And because I just did this on the test project, we've only got the unit test class at the moment. Ignore this auto-generated program. And in fact, in this diagram, you can't do this in the project one. The project one, you've got this filter in that pane I showed you before that was here. But in the type dependency diagram, you can press the delete key so you can edit this diagram more. Note that this diagram is not synced with your code. Once you generate it, then you can modify it, but it's not like two-way synced with your code, changing your code. I could have right-clicked on the solution level and done diagram show type, which would have included all the things. Another option is I can start dragging onto this diagram. So I could drag this on, or I could take a specific type. Let's drag this on so we get both types. So because I dragged the project on, then it's added the class, which has no dependencies. It's just, that's something I can actually delete. And we can see that now in the diagram. The shopping cart is being depended on by this. So we can see this blue line here. And again, we can click on this and see usage information. So I can show all usages or I can click on actual ones. It's worth pointing out that if you're trying to drag onto here, and as soon as you click on an item, it actually shows the code in the editor, which is stopping you from dragging it. If you click up here and behavior, you've got these options saying open files, project directories with a single click. If those are selected, that's going to block you from dragging. So make sure those are unselected if that's stopping you from doing this. So again, to interact with this, we can drag these around. We can control mouse wheel to zoom in and out. We can right click to pan. You can also hold down the Alt key to zoom in. So if I zoom out a bit and hold down the Alt key, it is flicking a bit there. Not sure why, but if I let go. So that's a good way if you've got a really complicated diagram of zooming in temporarily in different areas of the diagram. And again, later on, we're going to show a much more complicated solution to show a much more complicated diagram. If I control mouse wheel, zoom in a bit more, and let's delete this. I'm going to show you another way of adding something. So I can click on that and delete. So remember, again, this does not affect the actual source code. In this diagram, if you press the space key, then this pops up and you can search for stuff. So let's do class 1, enter, and that's re-added it. There are different ways we can get this diagram up. So we've already seen right-clicking somewhere here and choosing like diagrams and one of these options. If I close this and close this, let's go to the shopping cart. If I do find usages, so remember Shift and F12 or whatever your mapping is. If you're unsure, you've got your Alt and backtick for navigate to, so it'll show what that shortcut is. Or if Alt and backtick is different, you can click here and view navigate to see that alt and backtick. Click on this and see your find usages. So when you do that, and you've got the find usages down here at the bottom, then you've got this show on diagram button. So that's another way to get this up. That'll show those usages on a diagram. Another example, let's close that. Let's add an interface to this. So I'm clicking here and I'm doing Control Shift and R, which pops up refactor this. And again, if you're unsure, you can click here or Alt Enter, and you've got the refactor this menu here. So that'll tell you what the shortcut is, or you can just click that. And if I say extract interface, and let's make an interface for both, and then next. So that's now added an interface. If I scroll up, here's this interface. Let's Alt Enter on here and say move it to its own file. Okay. So it's asking if we want to add this to Git. So don't show that again. Yes. And it's doing that because it's a new file. Now what I wanted to show here is if I go to this interface and press Alt and End, then that takes me to the derived type. So going back to this interface again clicking here, navigate to, derive symbols, Alt and Enter, so that was that one. If I create another implementation, so Alt Enter, create derived type, obviously I'll have to call it shopping cart 2 or something other than shopping cart because we've already got one. Alt Enter, implement missing members, then enter again. So that's fine. Now if I go back to iShopping Cart and do that Alt and End, then because there's multiple, we get this drop down to choose which one you want to go to. And note that there is this button again. So there's a few different places when you're finding usages or doing things where you'll see this icon. So if I click on this now, then we can see this dependency diagram. So the interface and the different implementations. Another quick one, if I close this, Alt Enter, and then go down, we've got type hierarchy, which shows this pane on the right. So that's just a different view of what we've just seen. But there is, again, this button here, show on diagram. So as you can see, there's lots of ways we can use this to inspect the dependencies in our solution. But this is a very simple solution. And whilst that was useful for demoing and explaining these different diagrams, it's not very interesting. So let's have a look at a much bigger project. .NET Aspire. If you've not played with .NET Aspire, do it. It's amazing. But obviously that's out of scope of this course. But it's open source, so I downloaded the Aspire source from github.net Aspire. Basically this project. So I've downloaded this. It's not compiling for some reason, but let's ignore that. If we right click on Aspire and do diagrams, let's start off with the show project dependency diagram. And here straight away we can see that it's grouping these by these solution folders. So if we expand one of these, they've each got multiple projects in there. This one's got quite a lot. If I toggle this hide groups, then suddenly it gets a lot more busy. So this is kind of where being able to untick things, we can see down here, we can expand these groupings, these solution folders, and try and narrow it down a bit. So let's hide them all and look at components. So this is a bit more digestible. We can see lots of different components like Cosmos, Elasticsearch, Azure Service Bus, MySQL, Postgres, RabbitMQ, so lots of different ones. We can see some dependencies, so like Redis output caching project is depending on the Stack Exchange Redis. We can see that Azure OpenAI is depending on Aspire OpenAI. So let's close this, and I've no idea what this is going to do, but if I right click and try diagrams, show type dependency diagram on the whole thing, this is going to be a busy diagram. So that took about 30 seconds to get to this point, and it's warning me that it's high resource usage, but let's continue, see what happens. And that is the dependency diagram of the Aspire solution, the whole thing. With that level of detail, I don't know how useful it is, but let's just zoom in a bit and see what we've got. So obviously this is way too noisy. I've got way too much information, but it gives me an opportunity to talk about these different colors. So first up, let's have a look at this green dashed line. So that describes inheritance. So that's an inherited dependency. The blue line is usage dependencies. And you can see that we've got different thicknesses here. So again, the thickness shows how many usages there are. So you get an idea of strength of number of usages by the line thickness. And we can see we've got some thick ones here. We can see some things will have a green line. So that is when it's called an aggregated dependency. So that's either when it's part of a collection or a container of types. A purple line is a return type dependency. So if I drag this over here because it's appearing on my other monitor and hover, there we are. So that was appearing in my other monitor. We can see that named launch profile is a return type. And following that purple line down to here, that's extension method. So I'm assuming there's something there that does that as a return type. There's also a brown line which indicates a constructor injected dependency. So with dependency injection. A really good reference to the different colors and dotted lines versus straight lines is if you go to the JetBrains documentation. So their documentation is actually really good. And under code analysis, visual dependency analysis, explore type dependency diagram, this section, study dependencies between types, which you can get to here, then it describes each of these and it mentions the color of that entry and here as well. So obviously this is a very extreme example. I got a big project and did everything, but as we say, we can drag from here and just take what we want. You can right click and say diagrams, show type diagram at a different scope. We can drill down and even do it at a file level. So on a project this size, literally doing everything might not be a good idea. And then once you've done it, you can selectively delete. So remember again that once you create your diagram, it's not synced with your code as you're making changes. Or if you modify the diagram, that's not modifying your code. So you can then drag what you want onto it. You can delete what you don't want. And you can save as an image and you can export it. You can drag around the nodes and just position it how you want it. And there are various different filters to configure the diagram in a way that works best for your project and what you're trying to get from that diagram. So that now concludes the end of this module. In the next module, we're going to be having some fun with AI. In this module, we're going to look at how to use AI in Rider. AI is obviously huge right now, especially in our industry. And for transparency, up until now, I preferred to use OpenAI's ChatGPT in its own separate window, and I've been happy with it not knowing any more context than I tell it in the chat, and I just use copy and paste quite heavily from ChatGPT to the IDE. However, for this course, JetBrains have very kindly issued me with an AI assistant license so I could review it and cover it in this course, and I'm sold. Especially given I can pick the same ChatGPT 4.0 model that I use in ChatGPT anyway, and I get tons of IDE integration, which we'll dig into in this video. But first, let's have a quick look at the licensing details. So I've gone to jetbrains.com/AI, and this is a bit weird at the top. We've got these menu items, but if I scroll down just a little bit, I then get these menu items, which is more what I'm interested in. If we click on plans and pricing, this is how it currently is. So it's worth pointing out that this might change, and it probably will because this is fairly new. But currently at the time of recording, this is what it is. So you've got the Pro version, which is $6.58 a month. And obviously I'm looking at UK pricing. So that again will vary depending on where you're viewing this from. There's also this trial version. So you can trial it for 7 days for free. And there's an enterprise version as well. It's also worth pointing out, and I'm sorry for the sudden change to light mode, but if I change to this tab, there's this page, jetbrains.com, legal docs terms, JetBrains AI, service territory. Probably easier to find just Googling some of these terms, but this lists out the countries that it's available in. So it's not available in all countries. So if we jump over to Rider now, and I've just created an empty console application, so I've not done anything yet. So on the right-hand side, you can see this squiggly kind of icon. So that icon is the AI assistant icon, and we'll see that in a few different places. If it's not here, then again, on the left, look at this ... and it should be in here. When you click on it, if you haven't already got the plugin installed, there'll be a button here to install a plugin, and it'll talk you through installing it and entering your license details. I've already got it installed, so I've got this. Before we dig into this, if we do this ... and go to settings, then this takes us to the AI assistant settings. If we go to data sharing, this is worth pointing out. So this does mention here that as part of how it works, it is sending data to the cloud. If you're in a situation where you can't do that or your organization doesn't support it, then you can disable a plugin. But this does require actually sending the contextual information to the cloud. Going to project settings here, we can disable it for that particular project. If I cancel this, at the bottom, you've got this squiggly, the same squiggly icon. You can click on this and you can disable it for that project here as well. So if you don't want to disable it globally on your machine, but there's a particular project that you want to disable it for, then you can do that. So let's talk through some of the UI now. So there's only one option here in the AI assistant, and that's create new chat. If we click on that, then we get a kind of ChatGPT kind of interface where you can start typing questions, you can ask it things. But there's a few things going on here, so let's talk through the UI. So first of all, obviously we've got the prompt window here, but there's this above it which shows the current context the chat knows about. So the current program. I will talk about what this means shortly. You can add other files that are in your solution or commits or things to the context of this chat window. So that in itself is quite powerful, and also just being able to see what context it's dealing with. Also, this is amazing. You can choose the different model you're working with. So as I mentioned in the intro, I was previously using ChatGPT 4.0, but in the ChatGPT window. So using this, I've got confidence at a glance that I'm still using that same model. Or if I prefer to use Google's Gemini, I've got the choice there as well. You can even integrate with Llama, but I'm going to stick with 4.0. I might have said 0 before. 4.0, I think that's how you pronounce it. We'll come back to these things shortly. If we go higher up, then we've got all chats. So I can click on this and we've got a list of all the chats in the session. I can click on that, right click, and I can say rename or delete if I want. But if I go back to it, double click. There's also this drop down, which we saw before when we went to settings. There's various settings here, like rename the chat, delete it, adjust font size. I made that bigger for this video so we could see it, but you get this, so you can like make it smaller. You've got your managed license and various bits. So let's have a look at this now. So as soon as we've created a new chat, we've got some hints and suggestions of other things we can do. And these are really powerful. You've also got hyperlink all features, which gives you a whole bunch of information about the different things you can do, like complete code. If you click on that, it gives you an example and talks through it. So this is a really good reference for what you can do. So if I close that, we'll demo some of those features very shortly. We are going to use this to write some code in a bit, but for now, let's just use it for a very simple thing. Let's say print hello don't train. So I'm doing this just so we can see what the output looks like. So again, it's a very ChatGPT kind of experience where you're having a conversation with it, and it's giving us a code snippet as well as an explanation. We can see in my initial prompt that it's got this attachment, and we can see the two things that came with it, the ones that were down here at the bottom. And also in the snippet, we've got these options. We can say copy to clipboard, insert the snippet at the caret, so in the code, or we can say create a new file from the snippet. Note that those attached files have now gone from down here, so you can add more context, but the chat already has the context in the chat from these two. So you can add more files if you want to add more context. So you've got this hash or pound symbol, depending on what you call it, and you can reference other things. So like this file, a selection, if you've got a selection, you can reference files and things. So if I did, let's just do the CS proj. So that's actually done a mention of that thing. So I could say, explain this. And that's gone through, and because of that mention, you can see it's added that as an attachment as well to this prompt so that the model knows about that information. Because remember, this is sending this information to the remote service, and it's explained it as you'd expect. You can just type in hash and you get that drop down as well. You've also got this bookmark kind of icon, which says user prompts. If I click on that, then I think that's actually gone below my recording window, but there's just one entry saying add your prompts. If I click on this, then it pops this up. So then in here, you can say plus, you can add your own custom prompt. So let's say, tell me a joke, and put joke here. I'm hoping this is appropriate, but we'll see. And let's do that. So what you can do is click here and you can create your own custom prompts. If I do joke, then it's filled it in, and then I can submit that. That's actually pretty good. I'll keep that one. You can also, if you do that and choose add your prompts and go to joke again, you've also got this selection. So if I just do about selection and then save. So if you do it from here and just say joke, it always just does this code thing here. So that snippet doesn't seem to be designed for this. The snippet thing only seems to work if you right click and say AI actions and do it from here. So if I say, let's make that dome train, I'm going to regret doing this. And I select this and then I do and we'll come back to this AI actions again in a sec and choose joke. Why did Dome Train go to the coding camp? Because it wanted to stay on track with its .NET skills. I see what it did there. Not as funny as the last one, but anyway. So you get the idea. And you can see down here, it's got the selection as a context. That's what this does. So you can set up all your own different custom prompts. You've also got this drop down. You can say dump chat. If I click on this and just put chat, then this dumps out a text representation of that chat. So if we go back here, if you remember doing this, there was the AI actions. And this, you get this with most menus. So if I do Alt Enter, it's there. And you can, I've not done it, but you can assign a shortcut. So if you do that, this pops up. When you get that up, you get a bunch of options. You can say explain code, suggest refactoring, find problems with some code. You can start a new chat using the selection. So if you select a method or something, you can do that. You can get it to write documentation for you. You can do generate code, which I mentioned slightly before, but we're going to demo that soon with control and /. You can convert it to another language. And we've also got that prompt we created before and another hyperlink to take you to that settings page. So what we're going to do now is if I just start a new line, and I'm going to use that control / shortcut. So again, if we go to a new chat, that's the one that was mentioned here. So if we do control and /, we get this inline prompt. So let's go with write code to solve fizz buzz. So if you don't know, this is a common interview question. If I press enter now and let that write the code, then I'm given the option, do I want to accept or discard? So I'm going to accept that by pressing enter. And I actually want this to be in a class. So what I'm going to do is select that whole bit of code. I'm going to do control and /. So I've got this. And notice how it says, ask AI to modify the selected code now because I've selected some code. And let's say wrap this in our class. So I'm happy with that. I'm going to press enter. So that's accepted it. Something doesn't look right there. I'm going to alt enter and move this to its own file. That's better. I think it was because it was in program.cs, a class within top level statements. So just in case you don't know what FizzBuzz is, it's basically a common interview question where the programmer is expected to write some code which iterates through some numbers. And if the number is divisible by 3, it prints out fizz. If the number is divisible by 5, it prints out buzz. If the number is divisible by both of them, it prints out fizzbuzz. So this looks about right. There's probably things we could do with it. One thing, just from a code style point of view, I prefer to use var. Now I can obviously alt enter and say use var, and I can choose to do that across the whole solution if I wanted. But instead of doing that, if I go to the settings here, so the settings we saw before, the prompt library, so this is where we added joke. We've got this chat instructions, so I can actually say always use var. And then if I say save, and then let's just delete all of this. And we can now see, so on the right-hand side, remember how I said I would explain this later on in the video? So this now says always use var. So if I type here, write our class to solve fizzbuzz, this is doing it slightly differently. This is doing in our chat window instead. And it also explains a bit more when you're doing it in the chat window. And you can obviously, one thing with AI is don't just accept the first input. Iterate it and have a conversation and tell it what you want to change. Ask it questions if you don't understand things. But we can see that's honored what I wrote about always using var. So that'll use that for all chats now. So you can imagine that if I do settings, where were we? Project library for chat instructions. So you can imagine writing quite a detailed list here of your coding standards or any standard contextual information that you want the prompt to know about. So for example, controversial I know, but I personally prefer a single line block to not have braces. Again, very controversial, but I prefer that. I could just articulate that here so that I don't have to edit it every time. So this is quite powerful, and you can make this really long. Don't feel it's got to be like one line. It could be paragraphs worth here. So going to here, we can now copy it to the clipboard, paste it where the caret is, or add a new file. So I'm going to just insert the snippet at the caret, and small tweak, there's some suggestions. So I'm going to do Alt-Enter, move it to the right namespace. The file name it created before is slightly different, so I'm going to do Alt-Enter and rename the file to match the file type. Now I want some tests for this, so let's just create a new test project. New project, let's go for unit tests. I always choose XUnit. Let's do AI Assistant demo.tests and then enter. So we've got the context here. So let's say write some unit tests. So it's writing me a whole bunch of unit tests. If I scroll right down to the bottom, and then it's explaining them all as well, which we won't read through now. If I get rid of this and I'll say insert snippet at caret, and that's done that, it's not going to be able to find it because it needs a project reference. So if I do reference, remember we spoke about this in the last section, projects and add, and then we should hopefully have an underline so we can do Alt-Enter and then enter to import the missing references. And that's now compiling. So if we go to the top, a few tidy ups, I'll do Alt-Enter here, remove unused directives. There's a suggestion here, that's going to be namespace, so move to the right namespace. Then we're green, so I'm happy. So let's actually run the test and see what happens. If I do this and do run all, and they've all passed. If I now go back to the code, another thing I can do is if I select all of this and then go to the AI actions, and then we can do things like suggest refactoring or explain the code. So there's various different options here. So let's just do that. And without actually going through this thoroughly, we can just see that it's gone through, it's made some suggestions, it's describing why it's made the different suggestions, for example, using constants and that kind of thing. So you can see how this will be really useful. If you write some code and then you've got it working, but you just want to see if there's any improvements that could be made, you can see how just almost pairing with this AI assistant is giving you suggestions and feedback, and then you can ask it questions. You can say, well, if I did this, is this better? And it can give you the pros and cons and that kind of thing. So just having that conversation with this chat window is really powerful. And as I said earlier, where I normally use ChatGPT in a separate window, I'm constantly alt-tabbing to ChatGPT to have that conversation, where here I can just have it staying in my IDE. The last thing I want to show before we wrap up this video is we've spoken about Git and commits. If I let's just select a few things so I can commit, then you can see here, in fact, let's select everything. Then you can see here we've got that squiggly purple icon again, the AI assistant icon, and it says generate commit message with AI assistant. So I've done that, and it's looked at the changes, and it's basically written a nice commit message describing it. Now, if I go back to that settings we saw before, and AI assistant prompt library, then we can see this built-in actions here, commit message generation. So I've not changed this is the default one, but you can see how this is giving some information to the AI model of how to generate this commit message. So things like don't be too verbose, start with short sentences, no more than 50 characters, then leave an empty line with a more detailed explanation, which is the recommended format for commit messages. But just being able to explain this in English is so powerful. And obviously you can come in and tweak this to suit your company's requirements. So if I cancel that, you've also got a similar thing for PRs. Now, at the end of the Git video earlier on this course, I demoed this when we created the PR. So I've not got a PR here now, so I won't demo it again. But when you create a PR and it's filling in the title and description, you've got a similar kind of thing where if you've got the AI assistant installed and enabled, then as part of the PR, it'll automatically generate the PR title and description for you in a similar way that it's done for this commit message. So in the next video, we're going to take a look at using GitHub Copilot instead of this, because you might already have a GitHub Copilot license, so you might prefer to use that. There is a plugin to do that, and that's what we're going to talk about in the next video. So the last video was fairly long, so I'll keep this one fairly short. It's possible that you've already got a GitHub Copilot subscription, and you'd rather use this instead of paying for another subscription. If I scroll down and go to pricing, so this does the same thing as the JetBrains site with having to scroll down to get to this. If I do this, maybe they're using the same template, but looking at the pricing, so this is, again, this might change, but this is also a paid subscription. As far as Rider is concerned, if I switch to this tab, there is a plugin to support this. Now later on in the course, I'll talk more about plugins, so I'm not going to go through installing it now, but I will switch over to Rider where I already have it installed, and I'll just talk through the user interface quickly. So first of all, there's a few different icons. On the left, there's this one. On the right, we've got these, yet again, the hidden look in this ... menu. This left one does a bit of an introduction, so it's kind of like a welcome page. And it talks through a few of the different features. We don't need to read this now because I'm going to go through it. So let's close that. Over on the right, we've got a chat window. So this is very similar to what we saw using the AI Assistant plugin. And again, we've got this kind of like ChatGPT kind of interface where you can have a conversation and ask it to write code. We've also got a very similar plus where you can add files to the context. As it mentions here, I can do a / and choose one of these commands. So like explain, feedback, fix, and that kind of thing, or document to selection. So to demo this, let's just delete this class, and let's get rid of the tests as well. So one option is that I can start typing some code and it will try and complete it for me based on what I've started typing. And in this window here, it'll start doing suggestions and you can choose which suggestion you prefer. Another option is you can start writing a comment. So you can do a comment and say, implement a class that solves fizzbuzz. And literally me typing enter there has done this, and I can press tab to accept, which I'll do. Another small bit of the UI, which I didn't mention before, is down at the bottom, there's this GitHub Copilot icon. If I click on it, we've got a few options. So we can log out, it says the status. We can also disable completions, which is what we've just seen then. And there's settings. So there's various settings here as well. Another thing there is, if you press Alt Enter, so I mentioned in the last section, we've got this AI actions for the AI assistant stuff. There's also, with this plugin installed, you've got the open GitHub Copilot inline chat. So the Alt Enter, this is there, you can do that. And then you get a similar kind of experience where you can start typing inline as well. So as you can see, this and AI Assistant is very similar. I'm certainly not going to say which one you should be using, but I'm assuming you don't want to pay for both subscriptions, so I wanted to cover them both. So that now marks the end of this module. In the next module, we're going to be looking at performance investigations and CPU and memory profiling. Hey, so in this module, we're going to talk about profiling both CPU and memory. This isn't going to be a really deep dive into profiling techniques because that could be a course in its own right. My goal is just to walk you through some basic scenarios so that I can show you the tooling and profiling options that Rider provides. Before we jump into Rider though, I just want to show you this documentation. So first of all, they've got really good documentation, which is a great reference, but also there's a few tables in here which is worth pointing out. So if you go to the Rider help and then run, debug, test, deploy, performance profiling of .NET code, and memory profiling of .NET code. Before we jump over to Rider, the things I want to show. So for performance profiling, there's this table showing supported CPU architectures. So this is worth knowing, and you've also got one for supported frameworks for like .NET Framework and .NET Core and Mono. And also on the memory profiling, you've got a very similar table which shows the supported architectures and the supported frameworks. So that's a really good reference. For both of these, for both memory and performance profiling, it's worth noting this bit here. So basically .trace and .memory, they're separate desktop applications, but there's also Rider plugins that if you're using the .NET Ultimate or the All Products subscription, when you install Rider, they will be installed as a default plugin anyway. So if I go to Rider and go to Settings, Plugins, and we'll talk about plugins in the next module more, but if I type in dot. Then we can see we've got a bundle plugin, dot trace and dot memory, but that only applies if you've got one of these licenses. Also, I'm going to be showing the Rider UI for profiling and doing memory snapshots and things. But as I mentioned earlier, there's desktop applications, and there is some functionality that's in the desktop version that's not in Rider. And these are mentioned here. If I go up here, we've got limitations. Comparing the standalone version of .memory, some features are not available. Now, this might change over time, so again, refer back to this. So that's .memory. If I go to the performance profiling, then we've got a similar note that not all .trace features are available in .NET Rider, and the integrated profiler only includes these two views, which we'll be demoing shortly. So with that, let's move over to Rider and take a look. So I've got this example project which you can download from GitHub, and there are two scenarios. I've got one that does more the performance profiling, and then I've got another one which does more memory profiling. So the performance one is using a Fibonacci calculator, and this is quite a very inefficient implementation intentionally so that we can profile it and see what's going on. And we'll talk about this in the next video. And then we've got another one which just simulates some form of memory leak, which we'll talk about in the video after that, where we'll be talking about the memory profiling side of things. As a side note, you can see I've got a switch statement and I'm displaying some form of menu here. This is just so that I can run it and we can choose from a menu which scenario we want to run. For the menu, so I'm control clicking, this is actually using an amazing library called Spectre Console, which is here if you go to spectreconsole.net. I would highly recommend this if you want to do any kind of interactivity or enhance your console apps in any way. This is by someone called Patrick Svensson, and he actually appeared on my podcast back in episode 14, and we actually spoke about this. But I just wanted to mention the library in case you download the code and follow along and wonder how it's doing the menus. So we can see here it's literally just a prompt asking which scenario you want to run. So if I run that now, Control and F5, this is now running. We've got this menu here, so I can choose up and down which profile we want to run. Before we dig into running and profiling these scenarios, I just want to mention that when you run, and it could be run or debug, it might pop up automatically, but you've got this monitoring pane. So without explicitly profiling, you've already got this kind of graph showing CPU and memory usage over time. I can click on environment and see environment variables, and there's a few buttons here. I'll come back to that in a sec, but if I just click off the memory profiling one as an example, again, in the memory profiling video very shortly, I will dig more into what this is doing, but let's just run that now anyway. Then we can see this graph straight away. So without actually doing any profiling, just as you're working and you're running your app, we've automatically got this kind of information available. There are buttons here. So this is get a memory snapshot, which we'll talk about in the memory video. This one says collect stack trace. And this is really useful actually, just being able to click this, and it's going to dump out all the threads and all the stack traces. So we can see here that we're calling that method. And in this, there is a loop and there's a sleep for each iteration of the loop. So we can see it was in that sleep when I clicked on that dump stack trace button. And we can see the same for all these other threads as well. So just little things like that, which are really handy. We can start timeline profiling, which we'll talk about in the next video. And we can also choose when we want to enable this monitoring we're seeing right now. So at the moment, if I debug or run, this appears like we can see. I can choose to never do this or just when debugging. We can also see that because this isn't checked for me, and I think it's checked by default, that causes this to pop up automatically. But as you saw, I had to click on this one to make it appear, because I actually don't like it appearing every single time. So as I say, we get this without thinking about it. You're just running your application or debugging it and this appears. In the next video, we're going to look at doing a more explicit performance profile using this Fibonacci calculator code. So in this video, let's have a look at profiling this Fibonacci calculator. So just in case you don't know what the Fibonacci sequence is, basically it's a set of numbers where in the sequence, each number is the sum of the previous two numbers. So if we take this one, that's the sum of these two. If we take this one, that's the sum of these two, and so on. This calculator just takes a single number, which is the index into a sequence. So say I passed in 1, 2, 3, 4, 5. Say I passed in the number 6 here, then the return value would be 8. So that's all this calculator does. You pass in a number, it tells you what the value of the nth element in the Fibonacci sequence is. This, however, is a really inefficient implementation. It works, but because it's using recursion, now this might not be immediately obvious how inefficient this is. Okay, it's using recursion and it's calling itself, but actually each time we call calculate, that also then makes 2 calls. So if you pass in like even a smallish number, like we're going to use 45, you'll be surprised by how many times this method gets called. So this is the example we're going to use for profiling this. So how do we start? So we've seen at the top, we've got this play button and we've got a debug button. So we've used that a lot so far in this course. If you do this drop down, we can see this area called profile, and profile with expands out to show a bunch of options. The option that's here is just the last one you did. So if I profile with something else, then in this drop down, that's something else. Like for example, timeline would be here instead. You can also, I won't demo this, but you can profile a running process. So basically when you click on that, you get a dialog appearing with a list of all your processes. So you've got all these default options, and we'll talk about the memory ones in the next video, and we'll talk about these in this video. And you can click on them directly, or you can do edit configurations, and then you can click on them and just change the settings. And before we start profiling this, I just want to talk through some of these options because they're quite worth knowing. So for example, checked here is collect profiling data from the start. So as soon as you start profiling, it'll start collecting data. I can uncheck that, and then I've got a button to actually start profiling, because you might find that when you run your application, there's a few UI steps you've got to do before you hit the area that you want to profile. So you might not want to do it from the very start. You've also got this control profiling via API. Now this is really cool. From code, you can trigger, now is when I want to start profiling or take a snapshot and that kind of thing. And that applies to the memory stuff as well, not just the performance profiling. And there's a few other options like profile child processes, different types of time measurement. So like wall time is basically, the name comes from a clock being on a wall, but it applies to a stopwatch on your wrist or that kind of thing. It's basically actual time as time passes, where things like thread time is time within a particular thread. So it's not just as time passes by. Obviously, wall time is a very high resolution timer, but it is as time passes by. So all of these work slightly differently. And because this is the kind of thing that you don't do very often, and then at least for me, I have to go and remind myself when I do have to do it. Whilst I'm talking through this, I'm also going to reference the documentation so you can see where to look for a reference. So again, going back to this, and again, it's very good documentation. They've done a really good job. If you go to the profile applications page and scroll down, there's this table here which talks about these different profiles. So timeline is basically collecting temporal, so that just means related to time, data about threads, application events and multi-threaded things. It does mention that on Windows it's using ETW, so event tracing for Windows, and it does require this service running. So this is a separate process and it requires administration privileges. That's not required for Mac and Linux. It's a bit weird here because it says recommended for most use cases against timeline, but sampling also says recommended for most use cases. So that's a bit confusing, I think. But I do get the impression that you'd probably start with timeline unless you wanted something more specific. The sampling is more about accurate time measurement. So if you're measuring time within different method calls, note that it does say that the number of calls is not measured. If you do want the number of calls, and in our Fibonacci example, that's actually quite useful. Then if I scroll down, we've got this tracing, where that's kind of the other way around. So that's more accurate call count measurement, but the time might not be accurate because of the profiling overhead. Now this does take a lot longer, as we'll see in the demo. And there's also line by line, which is Windows only, and it does it on a line by line basis. I can't see this being required very often because you probably get what you need from the other ones. So that's enough looking at the documentation. Let's actually do a profile. Cancel that. And then I'm going to start from here and I'm going to say profile with. So I'm going to do timeline. And when we run this, we can say it's launching our project. And this has actually popped it up in another window where normally if I was running Ride, it embeds it, but now it's a separate console window. If I choose, so we don't want that one, that's the next video, demonstrate CPU profiling, enter. Then it's calculating Fibonacci. So this will take a few seconds. So I didn't mention this, but if we bob over to the code and go to program, then I'm calling 45 on that. So that's now finished. That's the 45th value. And then if I exit that, now we can see that this has got a percentage down here whilst it's sorting out the snapshot. Let's let that finish. Okay, so that didn't take long. That took a few seconds. We can see that the process has been crossed out because it's finished. And we've got our snapshots here. So this could be a list, but we've only got one at the moment. And this is the first time we've seen this window. So this is .trace. And again, to have this, you would need the plugin installed, which as long as you've got .NET Ultimate or the All Products pack, when you installed Rider, it would have been bundled in. I can now drill in on the snapshot by double clicking. I can also right click and say open in standalone .trace. So that's the desktop application we saw. But I'm just going to double click to open it in Rider. And we have this. So let's just drag this up a bit so we can see more. So we have a call tree here, which we'll talk about in a sec. We've got a list of hotspots, which is sorted by the percentage of time. We've also got this flame graph view. If I click on here, we can see kind of like a heat map kind of thing, I guess. And you can see that our Fibonacci stuff is a different color. Everything else is gray except for these. You can also right click within this and say scope to this. So rather than showing everything, it's going to drill down within that scope. If I close the flame graph, then this is being filtered down as well. And we can see along the top here, we've got a list of filters, and we can see my scope to this is one of the filters. So I could cross this out if I wanted to remove that. I can also filter by subsystem, so like user code, system code, link, file IO, and that kind of thing. I can filter by events, so like just-in-time compilation, memory allocation. I can filter by thread state. I can filter by an actual thread, and then there's the call tree. On the right-hand side, where there's these hotspots, there's a few filters here as well. So we can search. We've also got this, which is follow selection. So this is a toggle option. And by clicking this, then as I click here, then it shows the hotspots under that selection. If I have this unselected, then it's showing whatever the scope is. So do you remember we right-clicked and said scope to this? You've also got this, which is hide system functions. So if I uncheck this, we've got system functions. If I tick this, then those are hidden. So if I expand out calculate, which we can see because when we went to the flame graph, remember we scoped to this just to narrow the scope a bit. So if I toggle flame graph, and then hotspots is just toggling this right hand side. So if I see here, we can see that a lot of our time is spent in calculate, and without even looking at the code and only looking at this, we can see there's recursion going on. So we can click here and expand, and we can see this is just calling itself lots of times. So without even looking at the code, we can see this. Now, obviously, our code is very simple, so we could look at the code and see that. But imagine a big application where you've got some recursion quite deep in the code, which you don't know where it's happening. Or maybe not just recursion, but some performance issue. You can see how this will take you straight to where the problem is. Because one of the main goals is finding that method that's causing issues so you can investigate and improve it. And this will help you find that method. You've also got this backtraces button, which is kind of like a reverse call stack. If I click on this, then it's not that clear. So if I turn it off, and then if I go further down the call stack and I right click and say scope to this, and then I show backtraces, you can see it's kind of the reverse. Now you can see this being really useful if you've got a method that's called by lots of things. So you can actually see the tree of what's calling into that method. So in this case, we can see straight away we've got recursion. We can right click and say jump to source or press F4. It takes you to the code and we can look at it and see where the problem is. And as I say, this is a very simple example, a very simple code base, but it could be quite a large code base, and this can take you straight to that bit which is causing the problem. But as I mentioned earlier, looking at this, it might not be completely obvious how many calls it's making to this calculate. So what we're going to do is I'm going to go here and do profile with, and this time choose tracing. Because if you remember from the documentation I showed, tracing does method counts. So if I click on this, this does take a lot longer. So let's do CPU profiling, and I'm going to go away because this is going to take about 3 minutes. So I'm going to go and get a coffee. But when we come back, it's going to be quite surprising by how many calls are made to this calculate method. Right, I'm now back with coffee in hand, and this is now finished, and the timer says 3 minutes. It's only just finished. So if I press enter to exit that, and we now have a trace profile. If I double click on this and then make this a bit bigger, then it's a similar kind of view, but we can see we've got the number of calls now. If I go to the flame graph and I'm just going to right click and say scope to this and then close the flame graph. So let's have a look at this. We've got 1 call. Expand this. 2 calls, 4 calls, 8 calls. So this is power of 2 increment. 16, 32. So following in between these 2 lines, we can see we very quickly get to millions of calls. So you can imagine a developer creating this method thinking, oh, it's just doing a bit of recursion, it's fine, without really understanding that just a few iterations of it actually turns into millions of calls. But thanks to this profiling tool, we can actually look at the numbers and see that massive exponential increase in the number of calls. So let's close this down now. I just want to show you a couple of other things. So if you're in code, well, first of all, we can see here we've got rider just showing some information, just letting you know that's a recursive call, so it stands out a bit. You can also do from code, once you've got a snapshot, you can do Alt and Enter and go to Navigate to, which we've seen quite a few times in this course. If you've got a performance snapshot open, then you'll see this. If you've not, then you won't see it, but if you have, it's there. And if I click on it now, it won't do anything because I've not got the window open. But if I open it up and go to .trace profiler, and let's just reset my filters so that I've got something selected that isn't this method call. If I then do that again, I'll enter navigate to show in performance snapshot, then that's going to jump to that call. So it's kind of a two-way thing. From here, I can go to my code by F4 or right click and say jump to source. Or from code, I can go back to the relevant bit of information within the profiling results. I mentioned earlier about right clicking and saying open in standalone.trace. So if I quickly show that now, then we can view that in the standalone.trace desktop application. But going into this is out of scope of this course because it's a course on Rider. Before we move on to doing memory profiling in the next video, I just want to show that you can profile from tests as well. So I've got this test project. All it's doing is calling our Fibonacci calculator in the same way as we did from program, where we did this. It's just doing the same thing, but from a test. So we've seen in the testing module, you can click here and you've got run debug. We've spoken about run debug and cover, but you've also got profile. And again, if you go to the tests pane, so Alt F8, when you run from here, you can also do profile unit tests. So let's do that. Let's just take this one and profile it. We get this pop-up and we've already spoken about these. So let's just do timeline, which is a quick one. And that's now run. You can see that over here, it's still saying stop. So it's still doing something. So if we give it a bit longer, now this pops up, and in the same way as before, we can see that the process has ended because it's got the strike through, and we've got our snapshot here. So if I double click here, then we've got the same kind of thing. So I can click and drill down and see these calculate method calls. Because I just did a timeline profile, then we've got the times, but we don't have the number of calls in this case, because it was the tracing profile that showed us the number of times calculate was called. So that's certainly enough information to get started with performance profiling in Rider. As I mentioned earlier, to do a deep dive into profiling, that would be a full course, but that should certainly give you enough to get started. In the next video, we're going to look at memory profiling. So in the last video, we looked at performance profiling. In this video, we're going to look at memory profiling. And to demo this, we've got this simulated memory leak class. If I control click onto it to go to the code, then we've got this, which kind of simulates it-ish. If you've got a big complicated project, you might have accidental references that you don't know you're holding on to. And maybe over time, you're keeping hold of those references so the garbage collector can't collect them. And you've just got lots of memory hanging around which the garbage collector can't free up. So if this demo was C or something, or C++, so an unmanaged runtime, then this would be easier to simulate a memory leak, because if you allocate memory, you new it up, and you don't free it, that's a memory leak. But in .NET, it's much harder to make that mistake, because quite often you don't need to explicitly free it up because the garbage collector does it for you. So that's why here I'm just going to simulate some accidental references being held onto. So this code isn't a real world scenario, it's literally a loop, which allocate some memory. Imagine there's some code here which is just doing something. It doesn't really matter what. And then every so often, so in this case, every third iteration, we accidentally leave a reference to that memory hanging around. So in this case, I've just created a list for it. And then to slow it down a bit, we've just got to sleep for 1 second every iteration. So the idea being that the garbage collect will free up this memory unless it's the third iteration where we're accidentally holding a reference onto it. So this is the memory leak, but we can also see in the graph, as we saw before when we ran it, if I do that again, do you remember that we've got this monitoring? We've got the menu on the bottom. If I just demonstrate memory profiling, select this option, then if I just wait a minute. Okay, that's been about a minute, so we can see that the drop is where the garbage collector is collecting stuff that's not being held onto, but the general trend is going up because we've got this memory leak. Obviously, a real-world scenario is not going to be this explicit, and it could be hidden away in a really large code base. This is just an example, so we can see the UI. But if we stop this, and I'm just going to close this window, if we now do a memory profile, so in the same way as in the last video, if you click this ... profile with, we spoke about these in the last video, but now we've got memory, full allocation, and sample allocation. So let's do full allocations. So this has popped up. This time we want to choose memory profiling, so enter. And this is an ongoing loop, so this won't stop on its own. But if we go back to here, let's close some of these windows. So the Solution Explorer, let's close this as well. So we can see a similar kind of graph, just showing our memory over time. We can see information on the right, so things like the different generations for the garbage collection. We've got along the top, we can say get a snapshot. So if I click on get a snapshot now, we can see that appeared here. And we'll talk more about that in a sec. If I click get snapshot again, it'll create another one, and we can give it some more time. And now I'll click get snapshot again, and we've got a third one. You can see full allocation is on. We can actually toggle that and turn it off and back on again. We can also force a garbage collection. So if I do that, then you can see it just drop down. And because our code is just an infinite loop, it's a while loop, this will stop profiling either when the process stopped naturally, or I stopped it here, or I click kill here to kill the process. So if I do that, then we've now got our profile and we've got our snapshots here. So we can see bits of information here, but let's have a look at the comparison now. So we've got snapshot comparison along the bottom, and it shows one snapshot, and we can see this is checked here, but these aren't currently checked. If I take another one, then we get the snapshot comparison. If I click on the third one, notice how it unchecks the last one. So it only lets you do 2, and you've got your comparison here. I can then click on compare, and that'll show a comparison. So new objects are objects that are new since the first snapshot, the left-hand side of the comparison. Dead objects are ones that have been garbage collected, and survived objects are ones that have persisted between the snapshots. And we've got objects here, and then you've got the same for bytes as well. So we can see that the number of bytes is growing because we've got the delta there. On the left-hand side, I don't know whether a breadcrumb is the right term for it, but you can click on here and you can click back on here to go there. If I go back to the profile and do something else, so for example, say I double click on a snapshot, so that drills into the snapshot, then that's now here. So I guess it is kind of a breadcrumb. But by doing this, we get more information about that snapshot. So we get some nice charts, all of these things like sparse arrays and finalized objects. You've got an eye icon next to it. If you click on that, it will open in your browser the documentation for what that actually means. So for sparse arrays, it's an array that's been allocated but isn't really being used. And you've got various things like string duplicates, which aren't found at the moment, but that's multiple string allocations which have the same text data in there. And there's loads of stuff here, so I can like drill into things and click on specific areas to drill in and then go back in the breadcrumb. There's all these tabs along the top, so I can look at the types involved and go through each of these with different visualizations and information. So I can click through here. I can expand out here so we can see our list of bytes. I won't go through all of these, but if we look at instances, we can see this simulated memory leak, which is our class. If I double click here, then it's gone into that, and we can actually see that list which is causing the issue. So without looking at code, we can find the name of the field that's holding this memory information. So again, this isn't a deep dive. This is just showing the tooling that you've got. So hopefully this demo should give you enough to go on. If you do need to profile your memory usage and investigate a memory leak, for example. And in the same way as with .trace, which we showed in the last video, there's also a .memory desktop application. So you can do this within its own application. And I believe that has more functionality, which is what we saw if we go to the memory limitations. So it's saying some features and views are not available. And again, over time, this might change. The last thing I want to show in this video is if we go to Rider again, and let's do some debugging. If we go to this simulated memory leak, and I'm going to put a breakpoint here, and then I'm going to run the debugger, and then demonstrate memory profiling option. So we've now hit this. If I go to the right-hand side, we've got this monitoring. I mentioned in the introduction to this module that we've got this button here. So at this point, we can take a memory snapshot, and then I could continue my code, have a breakpoint somewhere else, and then take another memory snapshot. So then I can compare those two snapshots. So that's another option if you want to put breakpoints in specific bits and then have a comparison between those two snapshots you've taken. Another thing there is if I open this up, now I've actually changed this, so let me just change it back and then I'll explain. So by default, which you've probably got, you've got these tabs which I spoke about in the debugging module. And I can't remember whether I mentioned this, but if you right click on any of these, then you've got this layout. And I think by default, this is turned off, this memory. If I click on this, then threads and variables becomes threads and variables and memory. And you get this pane on the right. If I click on load classes, then it shows the memory here. And I can sort by like size, for example. And then we can see our byte array. It's certainly not as powerful as the snapshot information we've already seen, but I thought I'd mention this was there as well, just for completeness. So the next video is just going to be a short one, and it's going to show something really useful called dynamic program analysis. So with what we've seen so far, we've been doing quite explicit profiling. But what Rider gives you is, if you look at the bottom right, see how I've got this icon here? I think that tooltip's probably off screen, so if I just resize that a bit so you can see it, it's saying dynamic program analysis, one issue found. So if I click on this, so Rider does this in the background, and I can turn it off so it's optional, but out of the box, we get just these checks. So if I click on one, and then make this a bit bigger, we've got a new pane, and you can see this DPA icon here, and it's pointed out to us an issue. So in this case, the memory allocation, if I click on it, then it's pointing out that something, so without us even asking, it's warned us that there's something that is allocating a lot of memory. And going back to the AI module, if you've got JetBrains Assistant installed, you'll have this button here. So I might be looking at this thinking, well, I don't even know what that means. I can click on this and it will open up the chat window and explain it to me. And then I can obviously have a conversation with it to find out more information if there's anything I don't understand. So that's really powerful if I just close that. Going across these tabs, we've got memory allocation, we've got database, ASP.NET, and if I click on these, then obviously I'm not doing anything with the database at this point, and I'm not doing anything with ASP.NET, but you can see it's got context of actions, Razor page handlers, and Razor page components. If I go to thresholds, then we can see the thresholds of these warnings. So for example, the one we saw was this. We're not doing anything with the database, but you can see that it would warn if there was a command that was over half a second, or the warning could be based on the number of records. And again, the ASP.NET is time-based. You've also got, if we go to the actual code, we should see, so the same icon. So this is the DPA icon. So in the gutter, we can see that this is what triggered the DPA warning, and it gives information. I can click on it and say, view those issues, which goes back to here. Or if that's a non-issue, I can click on it and say, suppress it. And I can choose at what level I'm suppressing that. So that's really useful to know that exists and it's doing it in the background for you. And that now marks the end of this profiling module. As I mentioned at the start, this isn't a deep dive into profiling. This is just a drive-by tour of the tooling. But hopefully that gives you more than enough information to get started and start investigating any performance issues you might have. In the next module, we're going to be looking at using plugins and themes to customize and extend Rider.